Okay, so hello everyone. Thank you for the presentation. I'm Carlos Gómez. I'm from Spain. I'm part of the Active or Madrid team, and today we are going to talk. We are going to talk about phishing, new ways to trick the final user, the user that we have to phish to bypass or trample in the FIDO case. The FIDO and the PaaS case security measure that Microsoft put in place as kind of a standard like a few months ago. But we are going to see today we have some different things that we can do to the user never landing on this kind of security measure. So this is the index that we have on today. We are going to talk about some modern phishing techniques that we have on the sector over the years. We are going to explain what is a service workers, and then how we can leverage this and use the Cloudflare Workers to understand how the infrastructure that Cloudflare has and how we can use this kind of infrastructure to perform this kind of phishing. Then I'm going to introduce a bit of the FIDO and the PaaS keys, the FIDO standard and the PaaS keys stuff. Explain a little bit of how this type of invisible proxy works. Some coding stuff here will be very basic. Most of them will be JavaScript. I know the best programmer here, so please don't judge my code, but do the work. How we can perform the MFA downgrading, then a trick that I'll leverage here, I call it CSS injection, to remove on the fly some elements on the HTML page. And I have two demos here. Also, if we have time, we can perform a live demo. It's the last thing that I want to do today, but I have ready to do it. Then something that I call Evil PaaS is like the evolution of the Cloudflare stuff that I built it. Some tricks that I found offset, and two different deployments that I will publish probably in a month or two. Depends on the free time that I will have. That's always low. So, this is me. I have 25 years old. I'm security consultant at Active. It's my third year here in the company. I love red team, and of course I'm trying to improve myself as a malware developer every day. And when I have free time, I try to research, or at least try to find new things in the sector. On that, let's talk about some techniques. This is not a modern technique, but it's always better to have like the OG techniques that we all on the past we probably use it. So this is the classic phishing method. Basically this method is like cloning a HTML page and try to use it on our engagement. This is a very old method. In nowadays, it will be very difficult to use this on a real engagement, on a real operation, because most of the web application that we have in the sector is like progressive, dynamic websites. So this is a very old one, but I like to try to have this one here as a special mention. Then this one is called browser in the browser. You probably already know that this 6 exists. This also it's a little bit old because Microsoft put in place some security measure. Microsoft, Google, and the big ones, because these techniques will load some iframes over the file, and the vendors will block it. But browser in the browser is developed by my friend Dogs. He's a beast on phishing and initial access operations. I think very valuable the work that he have been performing this year, and how the value that he gave to the community and all the things that he discovered. Basically, this is the stacks that the text stack that this techniques has. You just need to know HTML, a basic JavaScript, and some CSS, and as I mentioned, basically you have a static HTML page, and you will have a button there that at the moment that the victim press this button, it will load an iframe and has this new tab on the browser that you can move, you can stretch. But as I mentioned earlier, the vendors on the sector block this and detect these kind of techniques at the moment that the page load a non-legit iframe that he detects. So this is how it looks. Small GIF that they take from the Docs, Mr. Docs website. As you can see, at the moment that you press the syncing with Microsoft button, is load the iframe and pop up a new tab. Next one, we have the Adversary AiTM. This is basically a man in the middle, but with a cooler name, as I said. The techniques that we will discuss later are based on this. So this is very common. We probably, all of you use it on your phishing operations. And it's like put the phishing server in the middle of the victim, and the Microsoft server rely all the communication to the Microsoft, write it and give to the victim to grab the cookies, username and password, and bypass the MFA, OTP, these kind of things. And, I want to give you a special mention on this tool, AVGX, whatever you want to call it. It's developed by Cuba, I think. It's become the standard on nowadays. If you don't want to build your own infrastructure, you will probably use the AVGX tool, and it's a really good work from him. Then we have the frameless browser in the browser. So basically, this is an hybrid method between browser in the browser and AiTM, Adversary-in-the-Middle, because these techniques works as the same as browser in the browser, but instead of loads an iframe, it will modify the web page with some CSS and JavaScript and relay all the communication to another server that is running AVGX. So with this technique, you won't have the problem that the vendor, like the security measure that the vendor has, that at the moment you load an iframe on the page, it will block it. So the tool that I will show you in the next slide is built by OAuth. It's a really cool tool. I really recommend you to at least try to give a try, because it's really funny to perform a phishing operation with it, to be honest. So as you can see, looks like the same as the other one, but the difference is the animation of the pop-up, of the new tab pop-up, is did by CS and JavaScript instead of blow out an iframe. And the tab that we see on the front of the screen is an AVGX server on other cloud server or whatever you want to build the infrastructure here. It's a really cool idea, to be honest. Then, no VNC. Basically, this technique will load web browser in kiosk mode, and it will give access to the victim through the web VNC protocol. It's the problem with this technique is if you want to use on real scenario, you need to tweak it, because the tools that you have online doesn't have some, at least for me, utilities that be a must, because it doesn't have like dynamic screen resolution. It doesn't detect the language of the keyboard that the victim is using on her laptop, and you will probably have some problems copy-pasting things on this key smoke web browser that the victim will pop up. Anyways, it's a really cool idea. I want to give a shout out to Joel. He developed the Evil No VNC, and then also to Juanetti, because he built like a fork of the first tool that gives us like the possibility to app multiple servers of these specific tools about using Docker containers, so you can have multiple sessions at the same time, because the original tool has a limitation on this, that you can only level up a Docker container at times, so you need multiple servers to perform. With this, you just need one server and multiple Dockers in the same server. Then, this is really new. I mean, it's pretty new. It's maybe a month ago, 2 months ago. I'm not sure about that. Basically, the file fix techniques is a click fix variation. Basically, the click fix techniques is a social engineer like attack that prompts the user to execute malicious code. And the problem or the limitation that the click fix had is the attack rely that the run dialog will pop up and the user will paste all the string or the payload, the uncovered payload on the machine. So that's why this technique came to our sector. With indeed is basically the same, because the attack chains will be to execute some commands via the file explorer. But on the address bar, when you have on Windows the address bar, you can execute some stuff there. But the way that you need to have here is, first of all, you need to have a phishing page. This is the thing that we saw here. Is basically the example that Mr. Doc has on the website. And this is a phishing page. It's put some instruction to the victim, and at the moment that the victim press the Open File Explorer, it will pop up a Windows File Explorer, and it will copy automatically the command on that address bar. We will show it later. So for this technique, you need to build, or you need to have a really good pretext, because at least on my experience, the last years, it's depends on the company that you are performing the engagement. It's really hard to perform sometimes phishing operation, because I think it's the companies, most of the money that they spend to train the people that working is versus phishing, trying to identify ECS, try to identify suspicious behavior on emails and that kind of stuff. But if you have a really good story, you have time to prepare the engagement. That this is something that sometimes is really hard to have with the scoping call and the stuff. So to perform this, you just need to have a good story to be success. But this is how it's like. This is the command. The file explorer is already down, and the way that this works is, at the moment, let me go 1 second here. The command that you are copying, it has an invisible command at the end or at the beginning, depends on how you code this, because it's just JavaScript with the spaces. It's not more complex than that, but Windows just detect the root and put this at as you can see here, it will put on the address bar, and the final user, if he do that in the correct way, doesn't detect that something is executing in the background. You can see another process pop up on the powers of one. Then, we are on the AI era. Phishing, the voice phishing has, with the AI has evolution a lot of because you can do a really cool techniques using AI to clone voice to other people and try to use it to try to phishing the engagement that we have. And I have a really cool story. Dave, it's a college from IOActive. He's a senior. He's a beast on red teaming. And we have a cool engagement on December last year. We were attacking a big private banking entity, and one of the points that they worry about is if we can develop in a very short period of time any kind of new TTP, new attack with this kind of new technologies that we have on the wall. So the way that we perform here is the CEO of the company. It's a really public person. So we found multiple videos of him talking on YouTube. We grabbed the voice of the CEO on YouTube. We use an AI program on GitHub. I mean, we didn't develop anything fancy because we didn't have time, but we took a tool that I don't remember right now what is it, but we took the tool, we put the voice samples that we grabbed from YouTube, and then we connect the iPhone, in my case, to the laptop, and we module our voice. We call it the IT department, and we fish it as impersonating the CEO, trying to we try to get the new password for him, and so we got success on that. It's really cool. I mean, IA able us to develop new cool techniques and new cool things that 5 years ago or something like that we weren't able to do it. And then the deepfake impersonation. I mean, this is a really cool video that we can put at the end of the talk. We have time. Of course, trying to impersonate very famous people is so easy because AI without data is nothing. So you need a bunch of data to do a quality attack or try to do a quality impersonation in this case. But, if you find a target, you need to find a specific target that you can grab samples from the internet, you can perform a really cool attacks. Then, for the things that we are going to discuss later, it's very important to understand what is a service worker. This is not new. This is something that programmers have been using a bunch, close to 9 years, if I remember correctly, because I'm not sure if we launched it in 2016. But, basically this is a JavaScript script that runs in the browser background. So when you are using a website, you will not notice that this is running on the background. You need to go to the dev tools, or maybe these things are doing some calls that you can, if you are intercepting the traffic, you can detect it from there. But, basically it's a JavaScript script that runs on the background of the browser and then do things. So this can enable the website to enable the performance. It can intercept and manage network requests. So this is something really cool for the things that we will talk later. You can catch things on these scripts to boost the performance of the web. It's really common to use this on CEO to perform some cool to boost the rank of your website in Google. And you can when you are using a website and you have a push notification and the website is closed, this is because you have a service worker running on the background. Then we have Cloudflare Workers. So I really want to thank Cloudflare to have this, because it's this technology enabled you to perform a really cool stuff, not only for phishing, for all the stuff, like you can build canary tokens, admin panel with one click, fake websites. You can rely and you can proxify some stuff. I mean, it's crazy. The easy that you can use this technology, because it's not plug and play, but it's really easy to deploy. You just need two commands, one for login and one for deploy. So this is always better. This is a service worker, but all the data is executed through Cloudflare, are serverless, so we doesn't need to have a big infrastructure to deploy these. You can perform tests in a really easy way, and you can these things like you don't need to manage multiple servers at a time, so that's really cool. It's the performance, because depends. Well, this is something that you can do with traditional or with the cloud servers. It depends of the zone that your client is. You will create the server on Europe or on United States or on Africa, wherever. And handle the global traffic efficacy. That means that you can create global apps, APIs, and website with high performance, because the way that this technology works is you can develop and you can adapt the zone, depends of where the attacked guy will be. And I have been in a situation that one guy was in United States and the other was in UK, so you can configure the workers to have it's not a server itself, but have two communication channels, one from the United States and one from the UK, and depends of the API, you redirect one to the United States and the other one to the UK, so that's really powerful, at least for me. Well, this is the FIDO and the PaaS keys is different things. We will explain now, but all the vendors in the sector are pivoting and trying to pivot to use this as a standard, because this will prevent a lot of the phishing. Well, if correctly configured, it will prevent all the phishing attack, at least in nowadays. So basically, FIDO is like a passwordless authentication standard. Microsoft implement this through the PaaS keys as a standard a few months ago. I don't remember exactly how much. I think it was in February or January, something like that. And as a standard, no implemented on the platforms. At the moment that you are trying to log in, it will be redirect automatically to use this. And the PaaS keys are like digital credentials, like storage in probably in a device like YubiKey, anything like this. So don't worry, I will have a workflow later to explain this visually. That is always easy to understand than using my works. But basically, the PaaS keys are digital credentials stored on the device. The private keys never leaves the device, and it will be connected to the public key that the server has at the end of the communication. Indeed, this the authentication flow is like a simple silent response, private key, public key. So it's really easy. I mean, the guys that do develop it are beasts, but it's the typically private key, public key workflow. And then the users, instead of introduce the password, will use biometric methods like fingerprint, face, and this kind of stuff. So let's see. I have multiple videos here. First of all, thanks to OAuth to give this page. I really recommend you to visit this page after the call or during the talk, because it's really easy to use, really visual, and it explains in a really good way how this standard authentication standard works with the passkey. So first of all, we want to register the user that we want to use to authenticate to the provider, Microsoft, Google, Okta, whatever. So let me, if I found the cursor. As you can see, we press the register button, the browser sent a challenge to the server. The server goes back to the browser, and the challenge goes to the device that you are connected to the laptop. Then this pop-up will appear to register a new passkey. So let me go a bit here. So at the moment that you press the button to register a new passkey on the device, it will send the challenge. Every challenge that you send over here will be dynamic. So just one use, you can't replay that challenge to reproduce this. And that's why doing like man-in-the-middle attacks won't work with all the things that we'll explain later. But, it will send you the challenge, the signature, the public key, and the raw ID. The raw ID we'll use to generate later the passkey. And let's go to the server, validate, everything goes good. And as you can see here, sorry for that, this is the next one. As you can see, the raw ID and the public key are all that you need to identify you, because it's like tagged. And we can process with the video. And this is the next one already. Okay, so we already created the passkey, and now we are going to use the passkey to authenticate to the platform. So we press the login button, browser communicate to the server, Microsoft in this case, and it will ask to use the Touch ID to signal to the web app. It's the website of the example, but using the guide that we registered already. And then we just have this. We use the Touch ID, the feed to connect to the browser, connect to the laptop connect to the browser, and then connect to the server of Microsoft to log in successfully. Basically, that is phishing resistant because the credentials are tied to the domain. So I have here. At the moment that you create a passkey with a credential, the user, and the domain that you wanted to authenticate, the origin of this are like binding, and when the FIDO key try to authenticate, the browser doesn't have access to this specific connections, so to this specific authentication workflow. So it can modify the the message that the FIDO key is sending to the server. The private keys never transmitted should be stored on the device to authenticate and access to all the passkey that you have stored on the device. You need to authenticate using biometric, like when you unlock the phone. And as I mentioned, every login uses a unique challenge, so the signature of this specific challenge cannot be replied for other use, future use. Then this specific, I have a quick schema here to try to explain in a better way how this works and why the adversary-in-the-middle attacks fails. In the left side, we have the victim already on our phishing page, and how the proxies works is we'll rely on this communication to the Microsoft server, and as the passkey are origin binding, it will detect that the location of the request will be from the phishing site instead of Microsoft, and that with that this will be enough to fail the whole communication, the whole attack chain. As you can see, this is as I said later, like the browser has zero control of the process because how the challenge works under the hood. Then I will explain how the invisible proxy that we are going to talk today using Cloudflare and platforms as a service works. I mean, it's already all the invisible proxy that we have on the market, but using all the platform and some cool tricks on it. We have an attacker, we have a victim, we have the original server. In this case, we are trying to authenticate to Microsoft. The attacker deployed the server. As we are using Cloudflare, it should be a Cloudflare worker. Then the attacker sent to the victim the phishing email, and if everything goes as expected, it will receive. And if the storytelling that we have is properly, the victim will open the phishing. It will connect to our phishing site, and he is already on our server, on our worker. Then to connect properly the Cloudflare worker or the evil worker, whatever you want to call it, you need to do some stuff because Microsoft perform a lot of validations on some specific parameters, encoding, cookies, headers, and another security measure that they have on the response of the servers. But with JavaScript and with this technology, you can control all the requests that you send to Microsoft and all the Microsoft send back to you. So that is when the magic happens here, because we have 3 steps. We have the victim connect to the invisible proxy that we need to perform some operation here to do like a smoothly connection, and then we need to deal with the connection of the visible proxy performed with the Microsoft server. And in the other way, when the Microsoft call back to our server, we need to perform some rewriting, some stuff to send back to the final user to connect correctly and don't have the pre-flight errors and this kind of stuff. Anyways, at the moment that the victim is already connected to the server, to serve on our proxy the original is not the original, but it's to perform the proxy-fied version of the Microsoft site. We need to perform some stuff that we send to the Microsoft send back to our worker. We perform on this step 5 some other activities, to give to the final user, to the victim user landed on our phishing domain. Right now, the user will land, if everything goes correctly, on our phishing page. He will introduce the user and password, or depends of how they have their tenant configured. Maybe they use the MFI directly. It depends of the operation. It could be one or the other. But he entered the user and password. And at this moment, I'm really fan of the webhook. So I have basically a webhook is a way that you can send data over HTTP to a server, because it's a lightweight protocol based on events. So you need to define on the code some rules to detect some stuff, in this case the user and the password, and at the moment that the server send that, it will send automatically to another server that we have the webhook stuff. Then we perform here the same stuff on the step 5. We need to perform on every request on the server some rewriting. And we got the callback here to the victim to use the MFA. And this is happening because in this step we will perform some MFA downgrading. Microsoft has implemented this in a really easy way. If you inspect the traffic of the whole workflow, we will discuss it later. And then the victim is already on the MFA landing page. He entered the MFA, connect to the Microsoft server. It's approved that everything goes as expected. Then we got the callback with the authentication cookies of the victim, and instead of stay on our phishing domain, I like to redirect to the official domain. So the victim will be out already to our proxy, invisible proxy, evil proxy, and minimize the risk to be detected by the proper user. And at the moment that we receive on the response the set cookies, we send that cookies to our via webhooks and our server that we have the webhook implemented, and then we redirect to the legitimate domain. So I don't know how I can call that. It's a really poor name, but it's evil Cloudflare Worker. Let's explain if you want to build this at your home. It's really easy, but anyways, I will publish a tool with all this stuff, but we will discuss later. Anyways, the main, the brain of the invisible proxy here is a main event listener. This listener is it's able to do this because we have a service worker running on the browser. So with this, we will detect every request and response that happening over our invisible proxy. So it's it will routing all the traffic over this, so we can control every request that we have. Request and response on the invisible proxy, and we have the total control of our server as normally, and because it's running on a browser level, so it's really cool to have this. Then another trick that I perform here is, if you inspect every authentication workflow that we have on the market, it will use multi-PS domains. So when I was researching this, trying to find a way to avoid Evilginix and these common tools that we have on the market with a lot of IOCs, this kind of stuff, I found multiple problems trying to map all the domains that we have on the workflow, because the idea here is try to hide as much as possible our phishing domain. So I came to this. Maybe it's not the best way. You can use whatever you want. If you have a better idea, just please say me, because but working. Basically, the first image, like the image that I have on the right corner, is on the left side we have our phishing domain, the magicx.help, and in the right side is mapping the original domain that we wanna map on the Microsoft workflow in this case. And this is the step when the victim tried to communicate to our invisible proxy. And in the right below corner, the reverse mapping array is saying the same. When the Microsoft saying the opposite, when the Microsoft responds to our invisible proxy, we need to modify this request to our Cloudflare worker to perform smoothly the operation. And it's really easy to modify if you want to use other domains to perform the phishing. You just need Command F and switch all the domains. So the next things that we have here is TS. When I was developing these, I have a big problem with the redirects that is happening during the authentication workflow, because the first time I didn't know why I have everything in place, everything looks like we're properly configured, but ever I sent the email to myself because I was testing it, I will land it on the original domain instead of my phishing domain. So, digging on JavaScript, I found that this is happening because, as you can see, the redirect manual. So, basically, by default, when you are using the fetch in JavaScript, it will automatically follow the redirects under the hood. So you are trying to control you are trying to control the traffic on the server, but JavaScript, do as always what it wants. So it will follow the redirects automatically. But if you switch or if you add the redirect to manual, you have control of every redirect that you have on the server. So this is a must. So this is the other thing that I have spent a lot of time trying to find how we can perform these actions. So basically, instead of following, automatically following the redirects, if this will give to the server a raw 302 request, and you can modify this request before you send to the final user. So with this you can modify the response content, you can modify the headers, you can modify the cookies, you can modify the encoding of some values that the vendors has, and it's the other must that you must have on your invisible proxy. Then, this is another thing Microsoft and all the vendors in the market, at least the big vendors like Google and Okta has also this in place. Microsoft are checking if the cookies that the server is issuing, like when the set cookies is in place, has a valid Microsoft URL that you define of the tenant, or you use the default one that most of the company has in place, like the login.microsoftonline.com. So as you can see on the screenshot below, when Microsoft send the cookie, it's Microsoft sent to the victim, so Microsoft sent to our invisible proxy server. As we have the redirect set into manual, we can modify that request, and instead of having the domain.microsoftonline, we have the evildomain.com. And then we have in the opposite way. When we are sending the request to Microsoft, we need to rewrite also the cookies to have a valid request and have a valid response in the future. Then this is not all the security measures that I have found in Microsoft, but most of them. The first one is you must check the response of the server, because you will probably find a lot of errors when you are dealing with Evil Nginx having like coarse errors, because it's about its executing of pre-flight request is executing a coarse error. That is happening because they have on the responses Ajax requests, so they are performing some requests before landing on the on our invisible proxy. The way it's really simple here is you just need to modify the response of the server before sending to our invisible proxy, rewriting the domain. It's basic. It's just that. Then we have the script integrity attributes. This is something that I have found on Microsoft, but other vendors will call it differently, but it's the same. It's like a hash that they have on their scripts. And at the moment that you are trying to, of course, if you are trying to use the signature of this on your phishing domain, it will fail. So the way I have managed to bypass this or to trick the browser or the invisible proxy to use this is identified where the scripts are located, and instead of having a value, have all empty value, and this works. This will work. Then the URL parameter writing, this is something that we will discuss later, but probably you have found on your operation that all the vendors have the same name on these values, like the redirect _URI. So this is also a must that you need to rewrite, and basically you just need to switch when you are sending the request from the invisible proxy to Microsoft. You need to use the Microsoft domain, and when you are sending the request from the invisible proxy to the victim, you need to use their victim domain. And canary HTTP header. Okay, this is at least I have on this 1 month ago, something like that. They added a canary header on the OAuth workflow. So this basically prevent the user to execute multiple logins at the same time from the same page. It's like it's not, but it's the same behavior when you are trying to execute a race condition that is, if correctly implemented, you only can perform one request per time. So performing this with the CS trick that we will discuss later, I have found that sometimes Microsoft add this header and prevent the user to execute multiple MFA requests, but you can perform OTP tickets. Anyways, you can delete this header and you won't have this problem. Then this is the redirect URI hijacking. You know, it's more cool say hijacking than rewriting, but it's the same. We will rewrite these specific parameters that you will find sometimes on the URL, other times you will find on the body of the request, and also you will find it on the responses of the server. So you just need try to find this specific value and switch, depends on in which step of the workflow you are. If you are sending to the victim, you need to use the phishing domain. If you are sending to Microsoft, you need to use the Microsoft domain. Why we need to send to Microsoft the Microsoft domain that the organization has configured on the tenant? It's because Microsoft is Microsoft and all the vendors in the sector are checking if the value of this specific variable is defined on the tenant of the organization. That's why you need to send a valid value to Microsoft. Okay, so I call this trampoline because, you know, it's not a bypass, because we are not breaking the FIDO and the passkey standard, but I have found two different ways using the Cloudflare Workers that smoothly trample in this FIDO new standard. So the first one is MFA auto guiding. This is not new, but the way that I perform here, if I'm not wrong, I think it's similar new, we will see later, and the other one is CS injector. This will permit us to modify the CES of the land page before the user sees, so the user won't be aware that something is happening under the hood, and it will only show two different options to use. Okay, so the first thing that you need to do when you are researching the OAuth workflow of a company is, I always do the same. I take the burst suite, I put the original domain, I try to complete the workflow, and found the security measures that they have in place. So, researching about Microsoft, they have this specific endpoint when you are trying to log in, and when Microsoft calls this endpoint, it will show these values on the response. Okay, so on December, more or less, this array was only the two methods on below, like phone notification and phone OTP, but when they introduced the passkey and the FIDO key standard, they introduced a new value, is the first one, the FIDO key. As you can see, let me go to the next one. You can see in the first value of the array, they have, on the JSON, they have the is default setting to true. So this is sending on every time that you are trying to authenticate with Microsoft. So I do a simple trick here is, first, let's see what I'm talking about here, because it's better to see how it's working. I introduce my account, I introduce my password, and the new workflow looks like you will land directly to the face, fingerprint, PIN, or security key. This is the FIDO or the passkey standard that they introduced a few months ago. Then, so you will probably already notice, but this is simple as to perform some regex. I love regex. I think I am the only guy in the world that like to do some regex stuff using JavaScript, but the only way, at least we are in nowadays, that we have to do here is switch the is default value to false, and then all the value MFA OTP setting up to true. And this is how it looks. So, 1 second. Let me stop. As you can see, this is the magic edge.help. We are on the phishing page. We are not on the legitimate like web page of Microsoft. Whoops. So authenticate. We enter the password, and then instead of redirecting to the FIDO keys, it will be directly redirect to the MFA. I know that maybe some companies has some specific users some policies that will be like ensure that the user that is authenticated just use the FIDO keys, but you know that is always when you are trying to introduce a new standard on the market, it came to a long time to every user in the world can use that, and a bit restricted about this, because if you force a user to use just the passkey, how you can recover this account? I mean, they need to build some. I'm not an IT expert, but they need to introduce a new way to recover this account if someone lost the passkey, if someone lost the way that he logged in this account. So the next one is CES injection. This is the web, like the landing page that you will probably land somewhere on your live. When you are trying to introduce the password and this kind of stuff, there is a button that is saying other ways to sign in. You will land it here. So the way I'm thinking, okay, how we can delete this without modifying directly the HTML, because this need to load the page, load the DOM, and then modify. So there is like a gap of seconds, milliseconds, that the user can notice that something is happening on the website. So the way I did it is just identify the div, the HTML of the web page, and I did a CS trick here, CS injection. I'm using the head HTML entity to find where this value, where these specific sections of the web page is, and delete it. So with that, the user just will see these two options, or in other cases, a profile application of Microsoft, and enter the OTP token. This is because it's on the before he entered the password or the MFA. So the user won't have any choice, and he just need to use the legacy methods. And I have a quick poke here. We are running out of time, so I need to go fast. But the user not notice that something is happening on the browser. And if you enter the password, sign in, and imagine that this I can use my Microsoft Authentication API, but right now it's only showing the two original values. Okay, so now we want the cookies. So which cookies do we need to perform the authentication? Which cookies we need to send to over using the webhooks to our server to then authenticate? So if you go to the Microsoft documentation, you just need to use these two specific cookies, SAuth and SAuth persistent. With these two cookies, you can authenticate. If you grab the cookies of the user, you can authenticate and hijack the session of that specific user. I have here the how I perform using JavaScript. Don't worry about this; it will be available online soon. This is as explained before. I really like to send these values using webhooks, because it's really easy to code, it's really easy to use, and it's really reliable. So let's this is my colleague Denito. I asked him to send me a photo to put on the talk, and he sent me this one. So he built me a custom webhook server to use here, and this is why I have these two POCs. Let me just introduce, on the right side corner, I have the phishing page. On the right side on the corner, I'm on incognito browser tab, and on the original domain, and on the left side I have the webhook server. So let me go. Okay, the guy entered the domain, enter the email, enter the password. And as you can see, it's sent it directly to the OTP. And at the moment that he entered this, we already have the user and the password of the specific user. As you can see, just two methods. So, and at the moment that he complete the MFA, he will redirect smoothly to. Let me show you here. Extension A. I press yes. And I will receive another webhook request on the left side. I need to reload. The guy, as you can see, is already on the original domain of Microsoft. So he is already out to our phishing page. We receive the cookies on the left side, and let me enter this. As you can see, I enter the value. I'm running out of time, so I enter the second cookie here, SAuth, the value of it, and enter here, save, reload the page, and I hijack the victim. account. This is a test account, that's why I'm landing here. But I have this other POC. It's the same, but I'm using my iActive account. The guy is landed, the same behavior. I grab the cookies, I grab the username. I use these cookies on the browser, and then I reload the original Microsoft domain and I'm in. And with that cookies, you can access a lot of different pages of Microsoft as the My Account, the device, and this kind of stuff. So, I'm running out of time. I have a quick conversation with docs saying, okay, what is the next step of here? Because imagine that Cloudflare goes down, all the operation goes, you can't use the infrastructure. So I developed something, I call it Evil PaaS. This is the question that I have in that days. So I call it Evil PaaS. It's basically a node.js file, single file that you can deploy on every PaaS on the market, AWS, Azure, DigitalOcean, whatever, and it's performing the same operation but in another way. We have a full server. We can do more complex stuff because it's a fully cloud server, and you can perform whatever you want in there. Obstetrics. This is something that I have done. I remove all the telemetry with regex, so anything, any request will disclosure my domain, our phishing domain to Microsoft. You need to be careful with the user agent and the original reference headers. Also, this is a security measure that some vendors has. You need to use the original domain when you are sending from the invisible proxy to the Microsoft Okta, whatever. And then I want to give a special mention to this post. This is a must read that you have. This amazing blog post. You will learn a lot of these OAuth workflows in the market. So I really recommend you to read this. Then this is something that I will publish in a month probably. So these two Cloudflare Workers, one is an admin panel that can generate canary links that have 10 users or whatever you want to, and connect to the Cloudflare phishing page. We will hide this page from the internet, so the user only can land to this page if he used the canary link that I generated on other the Cloudflare Workers. This is a POC, but we don't have time, but basically let me show you quick how this works. And deploying it on the admin panel. This is the admin panel. You can generate tokens. You can generate links, unique links. You have then the clicks that the user did perform, how many times, the exact time that the user accessed the link, and it's like when you detect a phishing campaign on the sector that they are using a similar behavior of that. So, and it should perform the same operation that I explained earlier. This is Evil PaaS. Evil PaaS is already available on Maldev Academy. I collaborate with them, so you can find in there. Anyways, I will publish a community, a GitHub project to everyone can access to it. So don't worry about it. This will be for all. And I want to say thanks to the organization, especially to Dylan. He's always very kind with me. He opened me his doors on Amsterdam 2023 when I was nothing. I was a young guy trying to give a conference about cars. And Daniel, he's my senior. I learned a lot from him and Mr. Docs that we are performing so cool things coming the next months. And this is all. Thank you for everyone to be here. And please, we don't have time for a question, I think, but I will be around. Please reach me when you want.
Thank you very much. We always want to make time for good content. So if you do have questions, it's lunch after this, so we can take a few minutes. Anybody, any questions from the floor that you'd like to ask while he's on stage? No? Lunch beckons, I guess. All right. So if you have questions, he'll be around throughout the whole day. So feel free to approach him off stage. Thank you very much for the cookie snack before our lunch. And we're now ready to break for lunch, and we'll be back here at 1 o'clock to continue this afternoon talk. Thank you very much, Carlos. It's a pleasure to have you back.